guys. In this lesson, we're going to be looking at really our first section in probability and statistics. And we're really going to be going through this. We're starting with kind of the simple things, and then we're going to work towards the more complex. One thing about this curriculum that we're using is there's a lot of word problems, and that's because that's where math comes alive, and that's where math is in reality. So we're going to start there. So you should see on your note pages, we're going to start here with our fundamental counting principle. So what that really means, that is if I have this first decision M, and I can make it M different ways. We're going to use a little m there. That just tells us how many ways I can make that decision. And I have decision N, and I can make it N different ways. Then together I can make these two decisions M times N ways. So what that really looks like is here's this example 1. An ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. So how many cones are possible if I choose 1 flavor and 1 topping and 1 cone? So here I see I have 3 different decisions that can all be made independently of each other. So I see I have 3 cone sizes, I have 15 flavors, and I have 8 different toppings. So following our fundamental counting principles, I can go ahead and multiply those 3 different values together. And this is not something you're expected to memorize, like have all memorized. So we're going to be using our calculator and Desmos a lot. So I have 3 times, and I know you can't see it, it's off your screen right now, but we'll use it in just a minute. So I see I have 360 total possibilities. So let's look at example 2. So I'm not going to walk you through every example in this video, but I will have all of these answers posted for you, either in our Google Classroom or on Blackboard, okay? So here, Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? So I kind of like to write it down. So I see I'm going to have 3 different letters, and then I have 4 digits. Okay, so each one of those things can be made separately, right? So each of my digits, or each of my letters, there's 26 different letters. So each of these possibilities, I have 26 possibles each time. Well, and then I look at how many digits, and there's 10 of those each time. So I see that I've got a total, and when I multiply this all together, let's go ahead and do this. And I use Desmos, and you can use whatever kind of calculator you like. Whoops, 26 times 26 times 26, whoa, times 10 times 10 times 10 times 10. So I see here for this example, I have 175,760,000 possibilities. So 100, what was that? 175, 760 possibilities. Okay, so now I want you to try these 2 examples and check out the answer key to see if you were correct. So the next thing we're going to look at is these factorials. So what does a factorial look like? And I know that you've seen this, you just didn't know what it was. So a factorial looks like something like n and then an exclamation point. And that's what a factorial is. So a factorial, when it looks like this, it is the product. And remember that whenever we're talking about product, that means we're multiplying all of the natural numbers. So natural numbers are those ones that we like count. So we multiply all of our natural numbers starting at 1 all the way to n. And those can be reversed, right? You can look at either the 1 first and the n, or switch those 2. So for example, 9 factorial really means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All the way. So the cool thing is there's usually a button on a calculator that will do this for you. So here's just the calculator on my computer. So I see it's right above the 9 actually. So if I hit 9 and then that factorial, it'll give me 362,880. Okay, so now I want you to think about these 2 as well, this 12 factorial and 8 factorial. This is really no different written like this, and we'll see where that's going to come into play in a little bit. We do have one special one, and that's if I have 0 factorial. That's just a special thing that's 1. Just kind of like when I take anything to the 0 power, it's 1. So now we're going to look at both permutations and combinations and kind of really start looking at what's the big difference between these 2. So in a permutation, and you see I have my permutation formula right here that we're going to use a lot. So in a permutation, it's an arrangement or lineup of objects in which order matters. So here order really matters. Okay, so we're going to look at some examples of these. So n, right, in our formula, this P stands for permutation. N is the total number of things I have available, and R is how many I'm going to be taking. So one thing that you don't have to memorize or really use is our actual formula of how we get there. So I know that in a permutation I have n factorial, and I divide it by my n minus r factorial. Okay, so that's not super important for you to memorize. I just kind of want you to know where it comes from. So then we're going to look at this important shortcut in a little bit, because I want you to try and come up with what that shortcut actually is. So let's look at our first examples. How many ways can you arrange the letters in the word dinosaur? And first we have to think, is this a permutation or is this a combination? Well, in here I see that order actually matters, because if I arrange them this way, it's a little bit different than if I arrange them another way. And you'll see some examples elsewhere. Okay, so here I notice I have a permutation, and I count that I have 8 letters in the word dinosaur, and I'm rearranging all of those letters. So I am going to use Desmos. You can use a graphing calculator as well. Let me just slide this over. So to find this in Desmos, you're going to go to your keyboard and click on Functions and then Stats. And here you'll see you have both combinations and permutations. Whoops, so let me clear that out. So I'm going to do a permutation here. So my n value goes first. So in this example, it was 8 values total, and I was taking 8 letters. So this tells me there are 40,320 ways that I could organize that. So let's go back to our sheet. It was 4320. So there were 40,320 ways. So let's look at example number 6. So 7 students are competing in a geography bee. How many ways can they finish in first, second, and third? So these words kind of give me a hint that it's a permutation because the order matters. So I have a permutation. I have 7 students that are competing, and I want to select 3 of them for those places to go. So again, I can go back to my Desmos, and I'm just going to change, and it will now be 7, 3, and it tells me that there are 210 ways that that can happen. So the other thing we're really going to look at is some permutations with repetition. Okay, so we really look at this when we're talking about letters and words, and I'm only going to walk through example 11 with you here. So, and I'm using colors. So first I want to figure out the things that are doubles. So I see I have those 2 P's, and then I also notice that I have 2 A's. Okay, so that's how I'm going to write that piece. So the rest of my problem, that becomes my denominator. And I see in this word, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 letters total. So this is kind of a weird way to do things, but this is how it works when there's repetition, and especially with letters, that there's multiple letters. So there's 9 possible letters, and 2 different sets of 2 each repeat. So then I would just put this whole thing in my calculator and kind of solve it from there. So the final thing we're really going to be looking at today is a combination. Right, so we talked permutations where order matters. So now a combination is where order doesn't matter. Okay, which is weird because we've all used a combination lock before. It really shouldn't be called a combination lock. It should be called a permutation lock, because here combinations don't actually matter. So again, you'll see your formula with our C, because it's a combination, with the number of things total and then the number of things I'm selecting. So where this really comes from is there's our formula for a combination. Again, not something you need to memorize. Here I want you to try and come up. Can you figure out what this shortcut is if I have my R value is the same as my N value? So let's look at a couple of these examples. So let's look at number 12. So Natalie has 16 close friends. How many ways can she choose 5 to be bridesmaids? So first thing I ask is, well, is this a permutation or a combination? So if I'm in the wedding, I'm part of the wedding party, it doesn't matter which order I was selected in, I was still selected. So that's going to be a combination. So I've got 16 total and choosing 5. So again, I just go back to my Desmos and I can add my new function. So then 16, 5 tells me I would have 4,368 ways to select those bridesmaids. Okay, so we're going to follow those same steps in these examples. So the last thing I want to spend a little bit of time looking at is that next sheet in your notes, and it says permutation or combination. So this is kind of really that important. I have to take in this information and figure out what I'm going to do with it. So look at example 1. How many ways can 4 candy bars be chosen from a store that sells 30 candy bars? So first question is we have to figure out, is this a permutation or is this a combination? So I know that if I have candy bars, they're kind of all in my bag, or I buy them all. So it doesn't matter which order I select them in, I still get to keep them. So that's going to be a combination. So then in my calculator, I see I've got 30 that I can choose from, and I pick 4 different ones. So then I can just plug this in, and you're going to go ahead and do this and actually find the answer. So let's look at number 2. How many ways can 13 students line up for lunch? So I know that I've got 13 students, and I'm picking all 13 of them. So we have to figure out, does order matter here? So when you see things like line or in order, that's going to give you a clue. So just thinking back, the order in which you line up, it matters. Because if I want to stand next to my friends, some ways I will and in some ways I won't. So that is where order matters. So that would be a permutation. So again, I want you to go and put this in your calculator and come up with our final answer. Okay, so I want you to look through the rest of these examples, and this is kind of similar to that homework that you're also going to be working on, but I want you to try these first because I have all of the answers posted. So once you get through these and double check your answers, really the first question you're always going to ask is this a permutation or is this a combination? Or really, can I just use that fundamental counting principle to get my final answer? And then you're going to use some technology, either your calculator or Desmos, to help you get there. Once you've gone through and done all of that, then you're going to sit down and kind of work on that homework sheet that I gave you and ask me when you get stuck on anything. Thanks, guys.